Numerical solution of ordinary differential equation, Euler's modified method. Euler's modified method. So, differential equation, it is given like this: dy by dx is equal to f of x comma y. Initial condition is given y of x0 is equal to y0. Then first you have to write the formula for Euler's method. So, formula it is yn plus 1 is equal to yn plus h into f of xn comma yn. Then improved value of yn plus 1 is given by, so first approximation yn plus 1 raised to 1, first approximation is equal to yn plus h upon 2 into the bracket f of xn comma yn plus f of xn plus 1 comma yn plus 1. This is the first approximation. Second approximation, it is given like this: yn plus 1 raised to 2. Second approximation is equal to yn plus h upon 2 into bracket f of xn comma yn plus f of xn plus 1 comma yn plus 1 raised to 1. So, this is the first approximation. Now, you see the formulas here. So, yn it is remains the same here, yn again this is yn, h by 2 it is the same, f of xn comma yn again f of xn comma yn this is same, f of xn plus 1 again this is xn plus 1 it is the same, change it is here only. So, yn plus 1, so this y1 you can find by the Euler's method, and this first approximation of y we have to find the modified Euler's method. Now, you can see the formulas. So, yn plus 1 is equal to yn plus h into f of xn comma yn. You have to put n is equal to 0. After putting the n is equal to 0, we will get here y1 is equal to y0 plus h into f of x0 comma y0. So, this is the Euler's method, and modified Euler's method you can see the formulas: y1 first approximation is equal to y0 plus h upon 2 into f of x0 comma y0 plus f into x1 comma y1. So, this y1 we have to calculate, it is from above formula from the Euler's method. y1 second approximation is equal to y0 plus h upon 2 into bracket f of x0 comma y0 plus f of x1 comma y1. So, we have to take here new value of y1 from the first approximation. Now, you have to compare both the formulas. So, this is the first approximation and this is the second approximation. So, y0 again y0 it is remains the same plus h upon 2 it is the same into the bracket f of x0 comma y0. So, this both same plus f of x1 comma y1, here it is f of x1 comma y1. For this y1 you have to take new values. So, this y1 you have to find from the Euler's method, and this y1 we have to take from the first approximation. Now, we will say one example. Solve dy by dx is equal to log of x plus y of 0 is equal to 1, then find y of 0.1 by modified Euler's method. Now, step number 1 we have to write what is given. So, here given it is dy by dx is equal to log of x plus y, this is given. So, I can write in this way: dy by dx is equal to f of x comma y is equal to log of x plus y. So, this is given. Then initial condition it is given y of 0 is equal to 1. So, y of 0 is equal to 1, I can write y of x0 is equal to y0. So, this is the initial condition. So, compare both the equations. So, from this you can find the value of x0. So, x0 is equal to 0 and y0 is equal to 1. Now, we have to find y of 0.1. So, I can write here y of 0.1 we have to find. So, I can write in this way: y of x1, this we have to find. So, value of y at x1. So, x1 it is given 0.1. So, from this we can find the interval. So, h it is the interval. So, it is a difference of x1 minus x0. So, x1 it is a 0.1 and x0 it is a 0. So, 0.1 minus 0. So, h is equal to 0.1. After finding this, we have to find the value of y1. So for this you can write the Euler's method formula. So formula it is yn plus 1 is equal to yn plus h into f of xn comma yn. You can put the value of n is equal to 0. So in this equation, so y1 is equal to yn, it is y0 plus h into f of, you can put the value of n, it is a 0. So x0 comma y0. Now to find this function, how to find this function? So first you have to write given function f of x comma y is equal to log of x plus y. This is given. See here, f of x comma y is equal to log of x plus y. This is given. We know the values of x0. So x0 it is 0 and y0 it is 1. So you can put in this equation log of 0 plus 1 is equal to 0. Now in the calculator you have to take ln. So ln 1 it is a 0. Then this value you can put here h, value of h it is a 0.1. So 0.1 into 0 it is a 0 and value of y0 it is 1. You can see here y1 is equal to 1 plus h it is a 0.1 and f of x0 comma y0 this is 0. So value of y1 it is 1. So step number 1, for the Euler's modified method we have to use the Euler's method to find the y1. Now we have to find the first approximation. So Euler's modified formula, first approximation. So formula it is first approximation y1 is equal to y0 plus h upon 2 into f of x0 comma y0 plus f of x1 comma y1 bracket complete. So first approximation y1 is equal to value of y0 it is 1 plus value of h it is a 0.1. So 0.1 upon 2 into bracket f of x0 it is a 0 comma y0 it is 1 bracket complete plus f of x1 it is a 0.1 and y1 it is a 1 bracket complete. Now how to find these values of function? So first you have to write what is given function f of x comma y is equal to log of x plus y. So here it is 0, x it is a 0 and y it is 1. So here you can put 0 and 1. So we get here value it is a 0. Then this function f of 0.1 comma 1. So equation it is log of x plus y. So x it is 0.1 and y it is 1. So from this you can find the value it is 0.0953. So this 0 and this 0.0953 you can put in this equation. So equation becomes 1 plus 0.1 divided by 2 it is 0.5 into the bracket this value it is a 0 plus this value it is a 0.0953. So first approximation of y1 it is 1.004765. After this we have to find the second approximation. So formula, so y1 it is the second approximation is equal to y0 plus h upon 2 into the bracket f of x0 comma y0 plus f of x1 comma y1. So this y1, this value you have to take from the first approximations, that is 1.004765. Second approximation of y1 is equal to 1 plus value of y0 it is 1 plus value of h it is a 0.1 divided by 2 into the bracket f of x0 it is a 0, y0 it is 1 plus f of x1 it is a 0.1 and new value of y1 we have to take from the first approximation, it is 1.004765. Now this function, so function you have to find the values for the function. So function it is given f of x comma y it is log of x plus y. So this f of 0 comma 1, so 0 it is x, 1 it is y, you can put in this equation. So answer it is 0. Then 0.1 comma 1.004765. So equation it is log of x plus y. So x it is 0.1, so log of 0.1 plus y it is 1.004765. So this is, so from calculate this and you can find the value of function. So it is 0.09963. Now all these values 0 you can put here and this value you can put here. So it is 1 as it is plus 0.1 upon 2 it is 0.5 into the bracket 0 plus 0.9963. Make the addition of this. After making the addition, you can multiply it with the 0.5, then you can add 1. So second approximation, it is 1.004981. Then you have to find the third approximation. So you can write the formula. Third approximation of y1 is equal to y0 plus h upon 2 into the bracket f of x0 comma y0 plus f of x1 comma y1. Here we have to take the value of y1 from the second approximation. Third approximation of y1 is equal to 1 plus value of y0, it is 1, plus value of h, it is a 0.1 divided by 2 into the bracket f of value of x0, it is a 0, value of y0, it is 1, plus f of x1, it is a 0.1, and we have to take the new value of y, it is from the second approximation. So it is 1.004981. Now we have to find value of this function as well as this function. So function, it is given by f of x comma y is equal to log of x plus y. So f of 0 comma 1, so x, it is 0 and y, it is 1. So answer, it is 0. Then we have to find the function value of this function. So f of 0.1 comma 1.004981. So this you can put in this equation, log of x plus y. So log is equal to 0.1 plus 1.004981. Value it is, or answer it is 0.09982. Now this 0 you can put in this equation. Again this value you can put in this equation. So this is the values. So third approximation of the y1 is equal to 1 plus 0.5 into the bracket 0 plus 0.09982. So make the addition here, then multiplication with the 0.5, then you can add with 1. So final answer of y1 for the third approximation, it is 1.00499. Now this is the iteration method. Now you have to compare the values from the approximation. It may be first approximation, it may be second approximation, and it may be third approximation. Now you can say there is no change in the values of y1 in the second approximation and third approximation. So value of third approximation, it is 1.0049, and second approximation value, it is again 1.0049. So final answer, it is y of 0.1 is equal to 1.0049. Thank you for watching the video.